going to go straight to the example here, and I believe there's a page over for more space here. Okay. So here we go for questions. Oh, sorry, yeah, good point. M3, scroll back, scroll forward. And there we go. 3.3. I don't know what he did. He used to be off passing. What was about?
He just left.
There they'll stay on top of them with the bloody bin.
Yeah.
Okay. Right, here we go. Particle is moving along a straight line with SHM. The amplitude, so I'm going to put that down, A is equal to 0.8. So I know that I've got a centre O. I know it's going to go to an extremity over here, which is 0.8 and 0.8 that way. And it says it passes through the centre O with speed of that. Now, if it passes through the centre with speed of that, what is that guaranteed to be? Maximum. Okay, when did I say the maximum? You've got to read between the lines here. So it's maximum when x equals 0. So that is x dot max equals 2. Okay, and I know this and I know that. It says calculate the period of the oscillation. Well, what can I pull out from this bit here? Well, specifically this bit just here. I know that using the formula for max, it only works for max, that x equals 0, therefore it is omega A. Okay, so I've got, happy with that, David? What are the formula we've got to use? Okay, you've got 2 is equal to omega, and you could just put that into, calculating, you'd be aware, I'm just going to write down 4/5. So times by 4 divided by, times by 5 divided by 4, did we get 2.5? So 2.5 rads per second. Okay, that's the angular speed we just worked out. Why do I want that? Well, this is all to do with part A. Why I want that is that now I can work out tau, which is the period, is simply 2 pi divided by omega, which is 5/2, which now gives you 4 pi over 5. Okay, and we're in mechanics, so I'd write that down, then I'd write down whatever it is works out to be. So I've got a fraction button, 4 shift pi, no, what have we put? Yeah, over 5. Scroll down 5, get equals, SD it, and we've got 2.51. So 2.51 seconds it takes to do a full revolution. Okay, everyone happy with that? Part B. Find the speed of the particle. Now, it's symmetrical. So, it says the speed of the particle when it's 0.4 meters from O. So, it doesn't matter if I look here or look there. The speed will be the same, just opposite. Okay, so I'm going to look here. It's halfway along. So, I'm going to put a point just here. X is what I want, and X is always measured from 0, and that is 0.4 meters. So, what I know for question B is that X is 0.4. I want the speed, so I'm going to need to know omega, which I've just worked out, is 2.5, and A, which we've been given, is 0.8. And if I'm after the speed, I don't worry about where I'm starting now. I just go straight to the formula, x dot squared equals, and what's the formula?
A squared, omega squared.
Omega squared, A squared minus x squared. Okay, so we're going to work this out. X dot squared is equal to omega squared, well, that's 2.5 squared. We've got A, which is 0.8 squared, minus, and we've got 0.4 squared. You do it all without a calculator, which I usually do, but I can't bother today. Square root, you're going to get plus and minus. Why did I say we're going to get plus and minus? Because whatever the velocity is doing here, whether it's going like that or like that at that time, it's the same. Or it's going to be the same at 0.4 this side. Okay, whether it's coming back or not, or going out. Someone got the answer? 3 sig fig? 3, is it? Yeah, pressed.
3 squared.
Oh, so it's root 3. Root 3. So x dot equals root 3 which is 1.7 something, is it? So x dot equals 1.73 meters per second. Okay. And the time the particle takes to travel 0.4 meters from O. So the time it takes. Now, this is where the question comes in. From O. So where did I start? It's wanting me to start at 0. If I'm starting at 0, which one did I tell us to start with? That's it, the one with a sign. You need to remember that circle is the one with a sign. That's how I remember it. Okay, so we're going to use, for part C, we're going to use x is equal to, and what's the formula? A sine omega t. Right. What does x equal? And it's measured from the centre, so that's fine. 0.4 is equal to 0.8 sin omega is 2.5 lots of t. Okay, so divide by 0.8 and arc sin it, and you end up with 2.5 t is equal to arc sin of that is 30 degrees, pi over 6, is it? So pi over 6. This is 5 over 2. 5 over 2, so it's going to be pi over 15, isn't it? T is pi over 15, which works out to be, what do you get, Brad? SD it? What you able to get SD?
0.21.
0.21, just give me one more figure.
0.209.
209. 0.2, it's usually 3 sig for this stuff. 0.209 seconds it will take to go from centre to there. Okay, and there's the answer. Okay. Right, anything at the bottom? No. Right, over the page. Example 10. Okay, we've got a small rowing boat. What was example? Was that example 9? What was example 8? Oh yeah, okay. This happened last year and I've changed it, but obviously I haven't changed the notes. So I'm going to need to get the book out, go to that. I don't want to miss any examples out because all of them are important. They test each little different thing. So what do I need to do? I need to go to whiteboard, which I've done. I need to go to a fresh page, which I've done. I need to get that thingy here, which gets rid of that, and gets rid of that, and go to the books, which are there, and M3, which is there, and then open the page anytime today. Right, scroll down. What's keeping me awake? Where are we now? That's rockets, isn't it? Rockets, oscillations. Which one did I say we're missing? 8, 9, 10, 7, 8. There it is. Right, if I copy the page, print screen, okay, and go back, which is just there, and edit and paste. Right. Okay, nearly there. Right. Zoom in. Oh, wrong way. I can just about read that. Do you want me to read it out to you? Right, example 8, it says a particle P of mass 0.5 kilograms is moving along a straight line, full stop, at time t seconds, comma, the distance of P from a fixed point O on the line is x meters. Full stop. The force acting on P has magnitude 10x and acts in the direction of PO. Okay, and here's the questions. A, it says show that P is moving with SHM. Is x meters, full stop. the force acting on P has magnitude uh, 10x and acts in the direction PO. Now part A says, show that P is moving with SHM, simple harmonic motion, and part B says, find the period of the motion. Now it's a regular thing, this bit here, showing that something's moving with SHM. How you prove something moves with SHM is you have to show this. This shows that something is moving with SHM. The acceleration has to be proportional to the displacement, but has always got to be facing inwards, okay, going towards the centre. So you have to show this. That's what you're always trying to get, that formula. So let's do a sketch of this. You've got a particle of mass of that is moving along a straight line. We've got O here and P there, and X increasing in that direction, and you've got a force acting on P as magnitude 10x and acts in the direction of P to O. So the force is acting like that. F is equal to 10x. Now remind me again, where is X dot dot acting? OP or PO?
PO. It's always towards P.
Where's X increasing? Okay, so it's OP. So therefore the acceleration is that X dot dot, the rate of change of acceleration is always in the direction of X increasing. Okay, I'll say that time and time again until you get into your heads. So it's that way. Okay, everyone happy with that? So the formula using Newton's second law states that, and I'm going to say that it's positive in that direction. Yeah, okay, I'm going to say it's positive in that direction. It doesn't matter. But anyway, I'm going to say it's positive in that direction. So force, which is 10x, is equal to mass times acceleration. So I've got mass, which is, what did it say it was? 0.5. 0.5. So mass is 0.5 times acceleration, which is minus x dot dot. Okay, so turn this around. I need to times through by minus 2 and end up with, therefore, x dot dot is equal to minus 20x. And believe it or not, you would say at this stage here that the acceleration is proportional, so the sentence would be the acceleration is proportional, proportional to the displacement. Displacement. This is a sentence that goes with it, and is in the direction of PO, therefore SHM. Okay. Now sometimes we're not asked to do this, but why is it useful for us to do this? What can I find? Omega. Well done. Okay. So we do this so you can find omega anyway, and you're going to need it because you need the period for part B. So that's part A. That's all part A is. Okay. With springs and things like that, with simple harmonic motion later, it gets a little bit more complicated, but not much. And here we go. Part B. From this we can see, therefore, what can I write down? Omega squared. Yeah, remember the format is this. So omega squared is 20. And therefore omega is root 20, or you could put down 2 root 5, isn't it? Okay, rads per second. Okay, so I know therefore that tau, the period, is equal to 2 pi divided by 2 root 5 pi over root 5. I know I should rationalise it, but I can't be bothered.